I am Sheladiya from Team 24. The other members of our team are Renish Jagani, Vivek Devre and Ananya Khandelwal. Here we have developed an Android application to simulate various concurrency and deadlock algorithms in an operating system. On clicking on this concurrency and deadlock button, the number of various algorithms which we have implemented in our project are shown. Let's start with the banker's algorithm. On clicking on this banker's algorithm button, theory regarding the banker's algorithm is shown. To understand the algorithm and for further explanation, we can play the video directly from YouTube. On clicking on this implement the algorithm button, one can start the implementation of banker's algorithm. First, we need to enter the number of processes, let's say 5 here. Next, we need to enter the number of resources, 4 here. Next, we will enter the total available resources. Here, it is 3, 17, 16 and 12. Now, one process is already given, so we need to add the 4 remaining processes by clicking on this add button. Next, we will enter the allocated resources and maximum need for all the processes here. After entering the allocated resource and maximum need for all the processes, we will click on this compute button. So here P1, P4, P5, P2 and P3 is the following safe sequence. To clear all of this, we need to click on this reset button. Now let's see an example where the system is unsafe. For that, the number of processes is 3, the number of resources is 2 and the total available resources are 4 and 7 respectively. Next, we will add 2 more processes and enter the allocated resources and maximum need for all the processes. After entering all the allocated resources and maximum need for all the processes, we will click on this compute button. So, the system will show the message that the system is unsafe for this particular example. Now, let's see the log variable. On clicking on the log variable button, theory and video regarding the algorithm is provided here, and one can start the implementation of the algorithm by clicking on the implement the algorithm button. A log variable provides the simplest synchronization mechanism for processes. It's a software mechanism implemented in user mode, that is, no support required from the operating system. It's a busy waiting solution and can be used for more than 2 processes. When log equals to 0, that is unlocked state, implies buffer is vacant, and log equals to 1, that is logged state, implies buffer is occupied. Initial value of the log is 0, that is unlocked. The state during the simulation will be shown here. Now, to see its simulation, we need to enter the number of processes. Let's say 5 here, and we will add the required number of processes by clicking on this add button. Now, to see the simulation, we need to click on the compute button. The first process called will directly enter the critical state, and all the other processes will enter the entry state until the process in the critical state is executed and enters the finished state. Once all the processes are finished and enters the finished state, the simulation will stop and the toast will be shown. Now we will see the Ostrich method. On clicking on this Ostrich method button, the theory and video regarding the algorithm is provided here, and one can start the implementation of this algorithm by clicking on the implement the algorithm button. Now we need to enter the number of processes, let's say 5 here. Now we need to enter the remaining processes by clicking on this add button. Now, to see the implementation of the ostrich method, we need to click on this compute button. As the processes are running, deadlock occurs randomly, and as per the ostrich algorithm, The system ignores the deadlock, so does our application, and therefore it will ask the user to restart the application. uh, and on clicking on this restart button, the whole application will restart. Now this is the simulation of the Ostrich algorithm in an operating system. Now let's see the binary semaphore. On clicking on the binary semaphore button, theory and video regarding the algorithm is provided here, and one can start the implementation of this algorithm by clicking on the implement the algorithm button. Binary semaphore can have only two values, 0 and 1. Its value is initialized to 1. It is used to implement the solution of buffer section problems with multiple processes. During the simulation, the changing value of the binary semaphore is shown here. Now, to see its simulation, we need to enter the number of processes, let's say 5 here. Now, we will add the required number of processes by clicking on this add button. To see its simulation, we need to click on this compute button. Here, the first process called will directly enter the buffer, and all the other processes will enter the entry state until the process in the buffer is executed and enters the finished state. Once all the processes enter the finished state, the simulation will stop and a toast will be shown. Now, let's see the counting semaphore. On clicking on this counting semaphore button, the theory and video regarding the algorithm is provided here, and one can start the implementation of this algorithm by clicking on the implement the algorithm button. The counting semaphore value can range over an unrestricted domain. It is used to control access to resources that has multiple instances. The counting semaphore value will be shown here. Now, to see its simulation, we need to enter the number of processes, let's say 7 here, and enter the semaphore value, that is the maximum buffer capacity, let's say 2 here. Now, we need to enter the required number of processes by clicking on this add button. Now, to see its simulation, we need to click on this compute button. The processes will enter the buffer state until the semaphore value is 0, and once the buffer state is full, the processes will enter the entry state, and until the process in the buffer is executed and enters the finished state. Once all the processes is finished, the simulation will stop and a toast will be shown. So, this was our Android application simulating various concurrency and deadlock algorithms in an operating system. Hope you liked it and gained the better understanding of the same. Thank you.